Hello, Algebra 2 Part 2. This is Section 812, which is writing quadratic equations when you're already given the solutions. So what we're doing is we're kind of going backwards from what we did in 811. In 811, we had a quadratic equation, and we had to solve it and find the solutions. And now we're given the solutions, and we have to use those to write the equations. So if you're following along with the PDF, our objective is to write a quadratic equation with all integer coefficients that is equal to 0 if the solutions are given. So a few key things right there is we want these to have integer coefficients. So that means our coefficients are going to be positive and negative whole numbers. And we're writing equations so that the whole answer has to be set equal to 0. It's not correct until you've gotten it set equal to 0 at the end. And so you can think about this as though we are working backwards. We're starting with the solutions, and we're using those to come up with the equations. So, a factored quadratic equation, under your first heading right there on the handout, a factored quadratic equation looks like x minus r sub 1 times x minus r sub 2 equals 0. And so these r sub 1 and this r sub 2, those stand for your possible solutions. So these were the numbers that you were solving for on last night's homework assignment. Okay? And so sometimes I've had some students who struggle with thinking about this as x minus r. And another way to think about it is just x plus or minus a number. Well, actually, we want to be clear, it's going to be minus times x minus a number equals 0. So the reason why we say it's minus is because what you do is you take the opposite sign of your solution and then you plug it in. Okay, so you're adding or subtracting some number to 0. So this is what your general solution looks like, and then the next step is you would go ahead and FOIL and simplify to get a quadratic in standard form. So that's ultimately what you want, is a quadratic in standard form. Alright? Now, so if I run through a really easy example on your classwork, just so you can kind of see what we're looking at here. So if I go to the classwork and we take a look at number 1 to start off with, our two solutions are 1 and 4. So the equation that we would write would be x minus 1 times x minus 4, and the whole thing equals 0. So what I've done is I just take these numbers and I plug them into this format, okay? And then we would FOIL. So my first x times x is x squared. My outer's negative 4 times x is negative 4x. My inner's negative 1 times x is a negative x. And then my last, negative 1 times negative 4, is going to be a positive 4. And then this whole thing equals 0. So then we would want to simplify this. Okay, so I'll get an x squared, combining the like terms in the middle, and I'll get negative 5x plus 4 is 0, and then that's the answer there. Okay, so that's the kind of answer that we're looking for. We'll go ahead and we'll do one more like this. So if we do number 2, let's see, actually let's make things a little more interesting. Let's do number 3, which throws in some negatives there. So for number 3, our two solutions are -1 and -2. So if we plug these into the format that we were given at the very beginning, x minus r sub 1 times x minus r sub 2 is 0. So what we're doing, remember, we're taking our solutions, -1 and -2, and we're plugging them into this. Now this already has a minus, so we're going to have two negatives. So it's going to look like x minus a -1 times x minus a -2, and the whole thing is 0. So these double negatives become positives, right? And you have x plus 1 times x plus 2 is 0. So then we would FOIL this, and we get x squared. My outers will give me plus 2x. My inners will be plus x, and then my last 1 times 2 excuse me, is 2, and that equals 0. So we can simplify that, and we'll get x squared plus 3x plus 2 is 0, and then that would be your answer to number 3 from the classwork. Okay. The other type of situation that we have to think about is, what if our solutions have fractions, or what if they are fractions? So there's another format that we can use, and we can use this format even when our solutions are whole numbers. So we'll say, what if solutions are fractions? So a more detailed way of thinking about this is, you could have bottom x minus top times bottom x minus top, and the whole thing is set equal to 0. So the bottoms that I'm talking about are the denominators of your fraction, and then the tops that I'm talking about are the numerators of our fraction. Okay? So let's see. So an example that we could do with some fractions, if we look at your classwork, we have, let's jump to number 13. So for 13, they give us 2 and 1/3. So that 2, well, let's think about this whole thing as 2 over 1 and 1/3. Okay? So then the 2 over 1, when we plug that into this set of parentheses here, well, my bottom is just a 1, so I'll have 1x minus my top, which is 2. Okay, and then my 1/3, I'll plug that in. My bottom here is 3, and then my top is 1, and then the whole thing equals 0. Okay, so then this is something that we can simplify. So we'll go ahead and FOIL. So 1x times 3x is 3x squared. My outers, 1x times a -1 is going to be -x. My inners, -2 times 3x is -6x, and then my last, -2 times -1 is plus 2, and then the whole thing is 0. So if we simplify this, we'll get 3x squared minus 7x plus 2 is 0. Okay? And so this is our solution there. So the key in this piece is that when you have fractions, if you plug them in like this, bottom x minus top, if you put your denominator in front of your x and then your numerator being added or subtracted at the end, when you go ahead and FOIL the whole thing through, it gets rid of all your fractions, and then you get something like this that has all whole numbers, which is what we want. Okay, we want all integer coefficients, all whole number coefficients. We want all the fractions to disappear. So let's do another one like that. Let's do number 14. So for 14, we have 1/2 and 3. And I'm going to think about this as 1/2 and 3 over 1. And then remember, we want to use the format bottom x minus top, right? So our bottom is our denominator, and then our top is our numerator. Okay, so First piece, 1/2. Well, my denominator there is a 2, so I'll have 2x. And then my numerator is a 1, so minus 1. Next piece, 3/1. My denominator is a 1, so I'll have 1x. And then my numerator is a 3, so that'll be minus 3. Right? And the whole thing is set equal to 0. And now we can go ahead and FOIL. So multiplying my first, so 2x times 1x is going to give me 2x squared. My outers, 2x times negative 3 is negative 6x. My inners, negative 1 times 1x is negative x. And then my last, negative 1 times negative 3 is a positive 3, and that'll equal 0. So we can go ahead and simplify this, and we'll get 2x squared minus 7x plus 3. That equals 0. And we're all done. Okay? So another example of how to deal with those fractions. The other kind of special situation that we have is when we have a 0 thrown in there as a factor. So this would be something like what you have in number 10 of the classwork. So the solutions that they give us there are 0 and 7. Okay? Well, 0, we're just going to keep, going about this. We're still using that format of x minus r sub 1 times x minus r sub 2, or if you like to think about it as x minus a number. Okay? So 0 is just some number, some solution, so we would have x minus 0 as 1, and then that 7, that would turn into x minus 7, and the whole thing is 0. Now, x minus 0, well, we don't have to write it as x minus 0. We could just say that that is x times x minus 7. And so that's where these kinds of quadratics come from, when one of your solutions is 0. So now we'll just go ahead and distribute our x, and we'll get x squared minus 7x is 0, and that's our answer for number 10. So we'll go through and we'll finish some of these classwork problems. And so remember, the formats that you can think about is you could have x minus a number times x minus a number is 0, or if you have fractions and you like this better, you can do bottom x minus top. Okay, so those are kind of the frameworks or the skeletons that we're working with here. So for number 2, our two possible solutions are 3 and 2. So that would give us x minus 3 times x minus 2. Okay, and multiplying that we get 0. So we FOIL this. So my first, x times x is x squared. My outers, x times negative 2 is negative 2x. My inners, negative 3 times x is negative 3x. And then my last, negative 3 times negative 2, that's positive 6, 0. So we simplify this. X squared, combine these terms in the middle. That'll give me a negative 5x plus 6 is 0. That's our answer, and we're all done. Let's go to number 11. We skipped over that one earlier. So for 11, we have 0 and negative 3 over 2. Okay? So, well, the 0, you can just think about that as x minus 0, and then we'll simplify that later to just an x. And then this negative 3 over 2, that's the same thing as bottom x minus top. So our bottom, our denominator, that's a 2, so we'll have 2x, and then minus the top, well, minus, and this is already negative, so we're going to have to throw that extra negative in, a negative 3. So, and this whole thing equals 0. So simplifying this, well, this x minus 0 turns into just x, and then what we have in parentheses here will become 2x plus 3. So now we can take this x and distribute that across, so I'll get 2x squared plus 3x is 0, and that's as far as we can go for that, for number 11, and that would be our answer there. So we have 2 more to finish up. So let's take a look at, so for number 12, we have 0 and 1. So we would do x minus 0 and x minus 1, and that whole thing equals 0. So that x minus 0 is just x, and then we have x minus 1. So we can take this x, distribute that across, and we get x squared minus x is 0, and we're all done. And then the last one that we have left to do is number 15. So I'm going to have 2 and negative 1/4. So that 2, we could think about That's just x minus 2. And then the negative 1/4, we can use the format bottom x minus top. Okay, so our bottom, or our denominator, that'll be 4, so we'll have 4x, and then minus the top. Well, so minus is part of the format, or the skeleton, and then the top is a negative 1, so we've got to throw in that extra negative. So now we're going to have x minus 2, whoops, and I forgot, that should be equal to 0. And then this set of parentheses, we can simplify our double negative, and that becomes 4x plus 1. Alright, so we'll go ahead and FOIL this. So x times x is 4x squared. My outers, x times 1 is plus x. My inners, negative 2 times 4x is negative 8x. And then my last, negative 2 times 1 is a negative 2, and that all equals 0. So we'll get 4x squared, and then 1 minus 8 is negative 7x, and then minus 2 is 0. And that's our answer, and we're all done. So hopefully you have enough to try the homework on your own.